In this lesson, we're going to be multiplying powers with the same base. Remember what we mean when we say a power. A power is made up of a base, which in this example is the 3, and an exponent, which is, in this example, the 4. So when multiplying powers with the same base, we keep the base and we add the exponents. So for example, if we're going to multiply 3 to the 4th times 3 to the 2nd, these two terms have the same base of 3. So we'll keep that base 3 and add the exponents. What does that look like? If we say 3 to the 4th, that really means 3 times 3 times 3 times 3 times 3 times 3. Well, we now have 3 as a factor 1, 2, 3, 4, 5, 6 times. So that would be 3 to the 6th. Of course, we're not going to do that every time and expand our multiplication like that. So we'll keep the base 3 and we'll add exponents. So that's 3 to the 4 plus 2, or 6. So we get the same answer. Let's look at another example. Algebraically, this means a number a raised to the m power multiplied by a number a raised to the nth power is equal to that same base a raised to the m plus n. In this example, we have 5 times x to the 4th times x to the 9th times 3x. I'm going to go ahead and use the commutative property of multiplication, and I'm going to move all of my coefficients to the front. So that looks like this, 5 times 3, and then I'm going to have the rest of my variable terms toward the end. X to the 4th times x to the 9th times x. And when we say x, remember that that really means x to the 1st. So if we look at this, we then have 5 times 3, which is 15, times, and we have the same base, x, so we're going to keep the base x, and we're going to add exponents, 4 plus 9 plus 1. So our final answer becomes 15 times x to the 14th power. Let's do another example where we have a couple different variables. We're going to follow the same reasoning. We're going to get all of our coefficients out front using the commutative property of multiplication. So I'll have a negative 4 times a 7 times a 2, and then I'll go ahead and write my variables in alphabetical order. I have a c to the 3rd times a c to the negative 2, and then I have multiplied times d to the 2nd. So if I go ahead and multiply my coefficients, negative 4 times 7 times 2 is a negative 56. Here I have the same base of c, so I'm going to multiply times c and add the exponents, 3 plus a negative 2. And now I have a different base, so I'm going to have to keep that term separate, times d to the 2nd. So in simplest form, this becomes negative 56 c to the 1st times d to the 2nd. And then finally, we can use this same rule to help us multiply when we have numbers written in scientific notation. I can still use the commutative property, remembering that scientific notation is simply two factors. And one of the factors is always a base 10. So I'm going to rewrite this with my first factors of 7 times 4 in front. And then I have my base 10 factors, 10 to the 8th times 10 to the 5th. So all I've done is use the commutative property. Now I can recognize these. 7 times 4 is equal to 28 times, we have the same base of 10. So I'm going to keep the base and add the exponents, 8 plus 5. So I have 28 times 10 to the 13th. Now that's not in scientific notation, so in order to put it in scientific notation, I'm going to move this decimal to the left once, so that factor now becomes a factor between 1 and 10. And because I had to divide that factor by 10, I need to multiply the second factor by 10. So that leaves me with 10 to the 14th. And my simplest form when multiplying these scientific notation values is 2.8 times 10 to the 14th.